Hi everybody. Welcome to Matt's Spellbook. I'm your host Peter, and basically we are going to continue on with the proofs that we were working on yesterday. So, let us get right into it. So hopefully you guys are doing well today. It is Tuesday, so I think I'm gonna erase the work that I was working on yesterday, because sometimes when I don't really complete something, I feel like the leftover stuff that I did the other day will just like kind of interfere with the process of actually trying to solve this stuff. So let us just get right into it, shall we? So today we're working on this proof. Hopefully you guys can see it. Hello, non-dairy neutrino. Nice name, by the way. Loving the name. Yeah, I decided to like basically like post that on because, like, you know, like I feel like some of you guys over there would like, you know, productive stream. I'm not really like an expert on like math or anything or physics, but at the same time I want to learn like both subjects. So basically, if you guys need to like relax, like need a little productive stream to give yourself a little bit of like that mind space of basically being productive, I felt like I should be your guy, you know? So right now we're like working on math proofs that I was working on yesterday. I managed to do one with the help of another person in chat. Yesterday I managed to solve this proof, which I'm really like surprised about, because I was like, did I actually solve this? And like the person in chat basically said, no, you solved it. And I'm like, oh great. Like the only thing I missed was this one little like less than or equal to sign, but they said, yeah, you solved it. And I'm like, oh cool. So now we're working on the proofs that we didn't do yesterday. We only have like 3 proofs to do, but if I don't manage to get through them like in this study session, then I'm gonna actually look up the solutions. So the solutions are already provided on the course that I'm the course that I already got on Udemy. So it's done by the Math Sorcerer, so like he knows how to teach, so I trust his word on it. Yeah, proofs, that sounds like proofs. Yeah, proofs like actually, like, are you studying anything, non-dairy neutrino? Since you're in my channel, I'm guessing like you must be also into math and physics as well. Let's see if we can figure this out here. So what we need to prove is this bit here. Yeah, because it says I don't know if you guys can see that. I'll try to zoom in a little bit more so you guys can see it a little bit better. And I'll try to make sure that my VTube model's not in the way too much. If it is, then I'll just like move it. Okay, so it says let B and A and C and D be numbers such that the absolute value of C is not equal to D. Prove that the absolute value A plus B over C plus D is less than or equal to the absolute value of A plus the absolute value of B over the absolute value of C minus the absolute value of D. Thought I would read it out loud for you. Just in case if you can't read my handwriting, because my handwriting is a little bit like chicken scratch, so apologies for that. So alright, enough of me yammering. Let's actually get this. So, the one thing I have to think about, and I will voice my thoughts out loud, so like you guys will have some background noise to basically just let the thought process like built in whatever it is you're doing, whether it be art or whether it be like actual like studying for school or classes or whatnot. I currently finished my master thesis in competition. Nice! Wish I was at your level of skill within math or physics, which is what I've been working on right now, but I got a bachelor's in math and physics. Nice. I actually would like if school wasn't so expensive, I would actually go back to get a bachelor's in math and physics. I would. Because I have a bachelor's in English, because I didn't find my inspiration for STEM until my last semester of university, actually. Nah, writing is fine. Oh, thank you. Thank you for the follow, non-dairy neutrino. I don't have like a notification, like a what do you call it? I don't have like a little bit of a fun little banner thingy that basically says this person followed you. I probably might have to make one eventually. But thank you for the follow. I appreciate it. Hopefully I'm giving you good vibes for like the work environment and stuff, and hopefully my voice is not too distracting for you. Might as well just approach these problems like Bob Ross, right? Okay, so now I gotta... So, the thing is that, do I try to prove for the right-hand side or the left-hand side? Because if it's the left-hand side, then this should be, like, similar to it. Oops. Erase that. Now, the absolute value of A and B. So the absolute value of A and B would equal A and B. That is if A and B are greater than or equal to 0, and for A and B less than 0. And I'm pretty sure it would be the same thing for... So actually, let's just drag it right here so it's not in the way. But how's your master thesis coming along, non-dairy neutrino? I'm actually loving your name, actually, non-dairy neutrino. I know neutrinos were mostly left-handed, but I never knew they were lactose. Yeah, so C, D. If C and D... Hopefully I'm writing this right. This definition, anyway. And then we'll just surround that and drag it over here. Okay. So either way, it's just going to be A plus B and C plus D, because it's always going to be a positive integer anyway. Well, that's my logic on that. I could be completely wrong on this. So now we have to figure out how to turn this into this. But how? Yeah, these proofs are basically based on, these proofs are from a real analysis course. Because I was like, I really want to learn like real analysis, but I know it's going to be extremely hard, but at the same time it was like, I just want to get to the proof writing, because every time whenever I do like books that show intro to proofs, it always starts with sets and logic. I understand why they do it, but at the same time I get really bored easily with them. And I'm like, can I just go into the proof writing? I want to know what the proof writing is. But then again, I don't want to rush myself into it, because obviously you need to know the basics. That's how math works. You know, I just get too excited, just like, can I just prove the magic already? But then again, I don't want to get too overexcited because, you know, obviously you have to know the basics. It's coming along. I'm in the final stage of building the tool. Nice. And it's on to actually using and analyzing it, and writing what I can along the way. Okay, cool. That's good to know. That's good to know. Glad you're I don't want to say project, because it seems like your thesis is going pretty well. That's really good. I'm guessing you're typing on like I don't know if it's called, I don't know if they pronounce it LaTeX or LaTeX. I usually say LaTeX, but I don't think that's correct. Like, I think it's because of math that I really wanted to learn LaTeX. But I haven't picked it up in, like, a long time, actually. Like, whenever I try to, like, do something that involves, like, programming or, like, coding or something, I do it for probably a couple days and then I just drop it. Well, not drop it, but I don't get back to it. Because the right side is much easier to break down because I wrote all this stuff on the side. The thing is that... Wait, I have some notes here. Oh yeah, I think I was looking at some of the proofs that were introduced. Here we go. Oh, we could do that. We could do that, because That's right. The reverse triangle inequality. So that means this is similar to this. Right? And that means this is similar to this. Perfect. Okay, we're getting closer. It's just that little teeny tiny, like, negative sign. We got to get rid of that negative sign and the absolute value bars over here. Based... Oh, that's very bad handwriting. Based on the reverse triangle inequality. I'm just gonna write it as like RTI. Well, sets and logic really are fundamental to analysis. Yeah, I know. There are certainly some good proofs to be done just with sets and logic as well. In fact, that would probably be the best place to start. Is there a textbook? I have several textbooks on real analysis, but I'm not currently using one. I'm just basically using Udemy to basically like watch the lecturer just basically give material out. So the course on Udemy that I'm using is by the Math Sorcerer. He's like a YouTuber. He's like a math professor / YouTuber who basically wants to get people into mathematics. So luckily he created a course on real analysis on Udemy, so I'm actually doing his Udemy course. I don't know if there's a specific textbook that he would want you to use, but I'm actually following his like lectures and like assignments that he posts on there. Okay. So this is based on the triangle inequality, so we managed to get this far. So we got the bottom half. Now we got to get the top half. The top half is going to be the thing we got to work with. Now I got to remember my basic algebra here. Oh hey, breathe deeply. Yeah, let's study together. Definitely. Hopefully I can be the good, productive background noise for you. Actually, I just noticed that I should drag this over here to the side so you guys can see it better. We'll drag it over here so that the chat doesn't block it either. But how are you doing, Breathe Deeply? What was the best part of your day so far? And also, non-dairy nutrient, I don't know if I asked you the same question. What's the best part of your day so far? And I think you already answered with, like, you're working on your master thesis. But then again, I don't know if that's the best part of your day. Okay, we got 30 minutes, so we're doing... I'm currently doing complex analysis. Oh, wow, nice. I am unworthy. I bow to you. I bow to you. I want to get to there, too. I want to get to there, too. Complex analysis. Calculus with complex numbers. I'm really excited to actually tackle something like that, because I know in physics they use that. And actually, non-dairy neutrino, like, since you already did your bachelor's in physics and mathematics, I know that I will probably ask you a ton of questions relating to both topics. My complex analysis courses was cool. Oh, nice, nice. I'm glad you're enjoying it. Actually, pretty deeply, I don't know if you told me last stream, but are you in are you currently in school? Or are you just doing it on? Are you just doing it for fun? Like doing uh math for fun? You're doing school, right? Because I'm pretty sure because you said math. You did say complex analysis course. All right, so now I have to get rid of this absolute value symbol. Well, the absolute value around the A and B, and then I have to convert the A and B. Ooh, wait. So we could do this. Oops. No. Not like that. Not like that. Plus. Oh, actually, that's a little bit too small. Too small space. We're gonna have to write a little bit wider. Right here. And then A plus B plus minus. Well. Oh, yeah, you're a student. Oh, yeah, from France. Oh, yeah, that's right. Yeah, you're from France. Breathe deeply. I don't know if you answered before, but, which part of France are you from? If you don't mind me asking. If you don't want to reveal that, then that's fine. That's okay. I'm just curious. Because I know someone who used to live in Paris, but then she moved with, I think, friends of hers, and she lives, in the suburbs of France, I think. Either suburbs or countryside, I don't remember. And B... Well, actually, it should be a minus sign. Yeah, we should leave the minus sign there. Plus... minus A. Yeah, the bottom part is done. We just have to get the top part here. Paris? Oh, okay. Wow. You should do some differential calculus. It's really powerful for physics. Yeah, derivatives, I think derivatives from calculus 1. I am okay with those. Obviously I know the power rule, I know dang, now I'm blanking out on the term. The product rule. I probably have to practice more on the quotient rule, because I hardly use that one. I love me some complex analysis. Nice. I heard Principles of Mathematical Analysis by Walter Baby Rudin is good. I never used it. I'm afraid of that book. I am really afraid of that book. That book scares me because I know that if I read it, I'll be so totally lost. I give creds to people that actually do it and actually get through that Baby Rudin. There's also, yeah, I also have that book. I actually have the physical copy of that book. Maybe I'll probably use that book whenever I study at night. Because the weird thing is that before I go to bed, I would probably try to look up something mathematical or physics related, and then I would probably just read it and then probably try to do some proofs from that. Well, not proofs. I would try to do problems. I mean. Did you see differential equations? Yes. Actually, when I was bored, I actually tried to learn differential equations. I think I got through basically around I think around exact solutions in first order linear differential equations, but I never did second order yet. So I have to get back into that. But I have to also take Calculus 3, multivariable calculus. I have not taken that yet. I do know things like curl and divergence and stuff, but I have to practice more problems with those. I am from the US. On the East Coast. There's a lot in physics. Yeah. Actually, I have to practice physics problems. I haven't practiced physics problems in a long time, actually. Ooh. So, if it's minus, does that mean we do this? Excuse me. Because then we have to distribute the negative sign across here. Oh, nice. Love America. Really? That's good. I mean, is it just like, because I heard in like Paris, like, I mean, it could be a stereotype or something, but I heard that people in Paris, they don't really care for like people from the United States. Is that just a stereotype then? What about physics? What did you do? For physics, I think I probably have to do like university level physics. Like, I would have to do like the basic of physics problems. So, I have to rework my brain around that. I did take algebra-based physics. I never took a class formally in calculus-based physics, which I probably should do. I think like with both classes, like you learn the same material. It's just that I think with calculus-based physics, you just learn a little bit more technical stuff. Yeah, it's a bit true. They have a bad vision of America. Oh, okay. Do you mind explaining that? I'm just like wondering because like I'm guessing we Americans screwed up by just being bad tourists there. That's my only explanation. But I think like every country experiences that. I think Japan currently is like they're worried about foreigners like just being a nuisance. Also, I probably should practice regular algebra. Oh, thank you for the follow, Tyrion 1803. Appreciate the follow. Hopefully I pronounced your name right, if you're in the chat. If you're lurking, that's fine. You're free to lurk if you wish. Because current laws as the right to... Oh, is that the only reason? Interesting. I thought it would be something like more... What do you call it? Like more like we're annoying as tourists. Hey, Penn Center, how are you? Actually, Penn Center, I should give you a shout out because you really have like a lot of content to provide for everybody. So I'll give you a shout out. So if you guys are not familiar with Penn Center, they are also a mass streamer. They provide a lot of content and also provide some courses. So if you guys want to get better at math, be sure to give them a follow. I try to attend their lectures as much as I can. And plus, Penn Center is way more brilliant in math than I am. I'm barely getting by. Oh, hey, Sensation. I didn't see you there. I guess I was just shouting out Penn Center. But welcome. Wow, everyone's like coming in. Thank you for coming in. Uh-oh. I guess I gotta click. Yeah, I gotta click. Okay, there we go. Okay, back to the proof. Okay, so for everyone that just came in, so the proof we're working with is this one. Let A, B, C, and D be numbers such that C is not the absolute value of C is not equal to D, the absolute value of D. Prove that the absolute value of A plus B over C plus D is less than or equal to the absolute value of A plus the absolute value of B over the absolute value of C minus the absolute value of D. I'm surprised I got through that without getting tongue-tied. Yeah, we got like a full chat. Awesome, guys. Awesome. I'm so glad that we're together. Thank you, I'm doing well. Just enjoy some morning coffee. Nice. I'm glad I could be the productive background noise for you guys. I'm pretty sure you guys are like looking at this problem. It's like, oh, I know what to do with this problem. For me, it's like, I feel like I'm getting close, but I don't know. Because I think like one part is like, one, I'm probably lacking the algebra because I haven't practiced algebra in a long time. Because we got the bottom part of this. I just need to get rid of the absolute values and get this to a plus sign. I just need to do that. But I have to figure it out. What is it that I must do? Wait a minute. Maybe I have to rewrite this. So let's just erase this. I have a habit of erasing everything a lot because, like, for me, it's like whenever I get my head like re-cleared, I erase literally like everything that I've done before. So let's do this. Because I just had an idea. I don't know if it's the right way to go about it, but we'll do it. Minus B minus A plus A. Well, then again, you also carry over the negative sign. Because I have to get you to I have to get you to equal to this. Do I have to square everything to get rid of the absolute value sign? No, right? Huh. How to get rid of the absolute value sign? It's like so close, but yet I am so far away. Because we got this from based on the reverse triangle inequality. Now I gotta figure out what is it that I'm lacking here. Actually, what is everyone working on? Like, or if you guys are just chilling, watching me rack my brain on this proof. You can say that as well in the chat. What is everyone up to? I'm creating a PowerPoint presentation about our data science graduates. Oh, fascinating. Trying to market to new upcoming students. Ooh, very, very interesting. I'm not surprised, Penn Center, because you put in a lot of effort to make like math very accessible to a majority of us. So, you know, like it doesn't surprise me that you're busy just being awesome at doing stuff for students. Let's see, I'm mashing my palms into the keyboard trying to force Visual Studio to do what it's told. And it won't. Aw, dang. I'm sorry to read the struggle, Sensation, but you could do it. You could do it. I believe in you. I mean, like, it's great that we have a lot of, like, awesome people that know how to program and are very, very scholarly in the chat. Actually, the thing of it is that for me, it's like, ever since, like, starting this channel, like, whenever I see you guys, like, post content about math and stuff, I'm so glad that I feel like I'm the dumbest in the chat for your streams. Because I'm like, wow, I'm actually the dumbest one in the chat. Like, it's very inspiring, actually. Because whenever I talk about math or, like, physics or stuff with my friends in real life, my friends don't even know calculus, and I'm like, oh my gosh, like, dang, like, they don't know what they're missing. But I mean, we could talk about anime and stuff, and like, you know, movies and stuff, so we enjoy other things. But math and physics, they're like, no, I'm not touching that. Me, scholarly, I'm just a wall puncher. Yeah, but at least you know how to program. Can I offer a suggestion? Kyobatsu. Kyobatsu. I know you said today, but what, like, Patsu? Kyobatsu? I feel like I've heard that before. Oh, Kyopasu. Oh, Pasu. Oh, Pasu. Okay. Oh, I didn't see the. Oh, I thought it was two. I thought it was two commas. I didn't see the. Oh, I didn't see the circle. Or what is it? Let's see. There's Dakden and Handakden. Yeah. Yeah. So I didn't. I think that's the Handakden. I didn't see the Handakden there. But Kyopasu. Okay. You'd pass on today. Interesting. Yes, you can offer. Oh, hey, Femvox fan. Yes, Penn Center. I'm getting to your question now. Yes, you can offer a suggestion. Please take the floor. Handaten? Oh, oh yeah. So, that's the little circle, like, next to, like, the hiragana, the katakana that you typed up. Like, so I think, Dakten and Handakten is, I think Dakten is when you turn, like, the H sounds into B sounds, and, you know, like, the other ones, like, you know, with the little, like, commas on the side of the hiragana. And the Handakten is basically the little circle that you put on the top of the hiragana, like, to make it like pop, ba, pi, bu, pe, po, in Japanese. I learned that from Detective Conan, so that's why I know it. Like, that's something you don't usually learn, like, in, like, basic Japanese, like in elementary Japanese anyway. I can't even remember what a verb is in English. It's fair. So English is hard. Okay. Wow, you guys are storming in the chat. I'm actually, like, I don't really get this much action even on my other Twitch channel. If you know, is less than or equal to, you know, we can't argue that satisfies what you want it to be. Oh, okay, so that's another way of looking at it then. I mean, the bottom part I got satisfied. Like, the bottom part, like, that's what we need. But the top part is just the thing that I'm kind of struggling with. Maybe I'll do that. So... Wait then. Wait. So if we did this, then basically the proof is done at that point. I mean, but then again, I haven't really fully proved it then. I mean, I haven't written out the full proof, though. Unless I'm, like, doing it completely wrong. The triangle inequality... Right. The reverse triangle inequality... So the reverse triangle inequality is... Because you said plus this, that is greater than or equal to, right? Okay. Okay. So we'll go with what Penn suggested. So that way we know we're doing this proof like solid. Because I'm not gonna urge that I know more than Penn or anything like that. Heck no, I'm nowhere near your guys' level. I wanna learn real analysis so I can actually read proofs. So I can like read proofs in topology and stuff, which is really awesome because I think like in real analysis there's a section on topology which I think is really funny because I'm like, oh wow. Let's see. I would think like this. What two ways? I make 1/3 bigger. One, I could increase the numerator. Or two, I can decrease the denominator half. Hope that intuition helps. Huh. Oh, nice. I'm nowhere near to be able to take topology. If I can make it to topology, that would be great. But I like, this is the first section of real analysis that I'm taking, and I'm like, oh, I'm not seeing it. Now I get why like most math students, when they're first taking real analysis, they're like, can you provide more examples, please? And then like the professor's like, I just provided you an example. It's like, but can you provide another one? Man, like if I was a student, I would be like completely like feeling stressed out because I would be like, dang, I'm not like, what is it that I'm missing here? Okay, so my question is now this: how can we make bigger? Slender did a great job yesterday in the linear algebra. Oh. Can you give an example? Make sure let it be integers. Yeah, because C and D cannot equal each other. Actually, I don't think I provided that in the... Well, I did say suppose. But then again, I don't know if that's enough to actually say that what we needed up here. Okay, so now I know, well, at least one thing I know is that I have to solve the left side to get the right side. And I think we're getting close, but it just keeps slipping away from me. Because I thought we had the bottom part, and the top part was just kind of like... Because the way I wrote, like, because, like, I'm just following lectures from what I've seen in the course by the Math Sorcerer. So basically, this is, like, the triangle, the reverse triangle inequality, and I thought that we had it because, like, when I saw, like, A plus C in this section, I thought we could write it like this. But then again, oh wait, so there's also a less than or equal sign there. So maybe I was wrong in that analysis. Yeah, because this one's the reverse. Okay. Hint, you know that... Right, and I think that's the regular triangle inequality. Let me see. In the notes. Yeah, that's the regular triangle inequality, so... Oh, wait. So, since this is the reverse, this one, we can't write a minus because then it would make that false here. So... Okay, so now we just have to convert the bottom, which is probably going to be the big snickerdoodle. I don't even know why I said that, but, you know. Well, technically that's the answer. Huh? Oh, is it because it's an absolute value? Because it doesn't matter if it's negative or positive, it just basically will be the... Intuitively, I'm letting you know that the inequality is saying that either increases the denominator or decreases the denominator. Or increases the numerator or decreases the denominator. So then... it will always increase the fraction you're working with. So what I'm getting at, Pen, what you're saying is that this... like, I'm not gonna say it's like the same or anything, but I don't know what to write. I'm just gonna put equals because that's what I'm thinking. You're saying this is like equal to, or at least close, or at least similar to this. We'll just write similar actually, because like I'll just put similar here. Is that what you're telling me? Or am I just missing something? That always increases the fraction you're working with. Increases the fraction you're working with. So like the absolute value of this would be less than or equal to the... Alright, so I'll probably do a trick that I think I learned from like one of you guys yesterday. Oh, hello, Maxi1921. Welcome. Is this from some sort of course? Technically, yes. It's from a course on Udemy that I'm taking about real analysis, by the Math Sorcerer. Because he makes like online courses, and I'm basically trying to do his real analysis course. Of course, I don't have any experience with proofwriting, so I'm actually trying to get my hands dirty with that. Oh, gotcha. Maybe I had my signs wrong. Yeah, because like because the thing is that like we need to get this to be a minus sign, this plus sign here. I mean, you're really helping me out, and I really appreciate the hints, because sometimes like my pride gets the best of me, and I was like, I don't want any hints, I want to figure out myself. But then I'm looking at a problem for days and weeks on end, and I feel like, ugh, like what am I missing here? But like during the next study session, because we're almost heading into the break time, after the break we're probably gonna go into the solutions, because like the Math Sorcerer does go over the solutions. So actually, a question for you, Pen, actually. How does this proof look? Right here, the one I circled here. So it basically says, like, since I have bad handwriting, I'll read it. Let A and B be numbers such that the absolute value of A minus B is less than or equal to 1. Prove that the absolute value of A is less than or equal to the absolute value of B plus 1. Oh yeah, so it should be... I start there and take the reciprocal on both sides. On each side. Yes, I know that the bell is up. I know it's break time, but I'm just gonna basically just look at what Penn wrote here. Oh yeah, it should be the absolute advantage. It's less than or equal to. Your proof looks good. Oh, okay. Thank you. Thank you. Yeah, the only thing I missed was this sign here. I put an equal instead of like less than or equal to sign. Like, I think one of you guys basically asked like, what do you miss? You're missing I'll let you find the second less than or equal to sign where you missed, and I was looking for it and I basically thought it was here. Because I kept thinking that, like, because since I'm so used to computational math, I keep putting equal signs where it probably shouldn't be. But thank you for complimenting on the proof. I'm glad that it looks satisfactory. But now is my time to actually chat with you guys, since it's a 15-minute break. I don't know if I probably should reduce the break. Like, I would have to find another video that basically does, like, I guess 10-minute break with 45 minutes of study time. Actually, what time is it? Oh, it's like 10. It's 2:50 on my end because I'm on Eastern Standard Time. Actually, like, is anyone like on a different time zone? I'm guessing, because I'm guessing all of you are on a different time zone. Because I think Penn, you're on Pacific Standard Time, right? I don't know about everybody else. It's 11:50. Oh, okay. Okay. Hopefully you're gonna enjoy your lunch soon. So I'm getting another coffee. Cool, cool, cool. I'm glad that I could be a good coffee break for you. 2:51 here. Oh, okay. So basically we're probably on the same time zone. Vox fam. Pacific. Oh, okay, okay, okay. Cool, 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 cool. But hopefully you guys are enjoying the stream so far, because like obviously like I am not as like a big math streamer as like some of you guys prestigiously in the chat, but you know, like I'm trying to be there, because like I've noticed that a lot of like math streamers, like they either already have their bachelor's in math or they just basically have done a lot of like math tutoring or teaching. So like they're very experienced in what they do. So for me, I just felt like, you know, I'm just the journey person. I'm just gonna journey into math and physics with like a background in only like maybe a little bit of Calc 2, like a little bit of Calc 1. So actually, like, since you guys are here and since we're practically on break, I can tell you what my goals are for this channel, or at least my life goals, not only with this channel, but also with my mathematical and physics journey. So, let me just look for the stuff that I want to put up for you guys. So, because right now I'm just trying to look for the stuff right now. So I am trying to, oh no, this is not the right one. Because I'm just going to basically present you guys with what my intentions are with this channel. So I just got to find both of them. Oh, no. Let's see here. Road to reality. This is, okay, so my intentions with this channel is to basically be able to study enough math so I can understand these two books. So I want to be able to understand this book, which is Mathematical Methods for Physics and Engineering, because I've had this book for so long in my shelf, but I have not been able to like pick up and like fully understand the content, because I guess like it focuses on learning math in a more technical way. In addition, I want to be able to learn enough math so I can understand this book, The Road to Reality by Roger Penrose. So, like this book, I really want to read because I feel like it's a massive spell book for me, to understand like how math is applied to physics. Because obviously Roger Penrose is a big name, and you know, like he's a mathematical physicist. So I want to be able to understand this book. Like, I did understand a little bit of chapter 1 to chapter... I think chapter 3? Oh, no, chapter 4. But then when it got to the geometry of, like, logarithms and power rules, I think I understand a little bit of it, but not a lot, because he did get into the complex numbers. And then when it got to real numbers and calculus, he then talked about, I think, the radius of convergence. And I knew I never covered that in my Calc 2 course. I didn't even my Calc 2 course, when I actually went to school to try to do engineering, which I dropped out because I was like, no, I can't do this. I already have a bachelor's in English, but at the same time, I'm like, when I went back to school, I was also working to try to get like an engineering degree. I was like, no, I can't do that. I can't do it. Is that Penrose? Is that Penrose not the popular science book? I think I don't know if it is popular, but it's a book that I looked at and I saw it was 1,000 pages. But when I looked through it, I was like, oh, there's got to be a lot of information in this book. And when I read like the first 4 chapters, I was like, oh yeah, I'm definitely going to learn a lot from this book. Because like what Penrose does is that he doesn't skip out on the math too much, but the way he explains stuff is that you can tell he's being technical, but sometimes he unintentionally becomes technical without trying to be technical at times. So yeah, so I want to be able to understand like Penrose's like ideas about, you know, the universe and like his point of view on yes, I remember that. I actually remember that interview. I was surprised that Joe Rogan actually interviewed Roger Penrose, and I wondered if Joe Rogan actually understood what Penrose was talking about, especially when he was explaining Goebbels' incompleteness theorem. And actually, I kind of follow Penrose's interpretation of Goebbels' incompleteness theorem. That like the way he explained it, I think, is like I had to rewatch the clip many times to understand what Penrose was saying. I think what he said is that if you think that the rules are fully laid out, then basically there will be truths that you cannot prove with mathematics alone. But from his interpretation, he basically explained that the rules have to continuously have to evolve. In other words, there's no end to mathematical rules. If you believe that there's an end to mathematical rules or mathematical like techniques, then basically you won't be able to prove certain truths. I mean, that's my interpretation, but for those of you who actually are like, you know, who actually are like working mathematicians who know math more than me, you can correct me if I'm being wrong here. But that's my interpretation of what Penrose said about Goebbels' incompleteness theorem. The math methods book will have a different approach and tone, as it's math for physicists and engineers rather than other math books. That's math for mathematicians. Yeah, because there was one part in where is it? Yeah, there's one part, like, they do go over like the algebra you're supposed to know, but then there's this part in about polynomials, like the roots of the properties of roots. And when I saw this form, I was like, what is this? I knew you're supposed to get the coefficients of the polynomial this way, but the one thing I never understood is that how are you supposed to use this to get the coefficients? That's the one thing that I was kind of confused about. I've been going through a similar math methods text by Mary Bowen. Very enjoy. Oh yes, I do have that book. I have that book. I have that physical book. I think it's because I haven't read that book because like I have to work on what is it? I have to work on Infinite Series because there's so much about Infinite Series that I totally missed, and like I did pass my Calc 2 course, but I took it in the summer, and that's a bad idea to do because I just managed to study enough for the test, but I didn't study enough to the point where I actually was able to get an intuition of how infinite series worked, or how trig integrals, as well as trig substitution. So yeah, the first chapter of a book is series. Yeah, because like for me it's like I know there's like series tests, and like you have to also know how to do like, you know, like calculate sums of series, but I haven't developed the intuition for series yet. So maybe like during one of the streams I probably should do series, like series problems, like probably do a review on Calc 2, because actually Calc 2 I barely remember the washer and the disk method. I barely remember it, and that was the first thing we learned in Calc 2 for the course I took before I dropped out. Like when we first learned it, I realized that, oh my god, I'm so ill prepared for Calc 2, and I didn't realize how hard Calc 2 was until I actually was in the depths of it. I mean, I did get A's for the test. The problem is that the homework was super hard, and I was like, oh my god, why am I struggling so much? But then again, like, it was my fault for not studying ahead of time, especially for a summer course. So yeah, if you guys are gonna take math in the summer, study ahead of time. You're not gonna regret it. And I loved math at the time, but at the same time, I just wasn't prepared because I thought I was gonna learn everything during the course. I mean, I did manage to pass the course, it's just, I just barely remember everything from it. Like, what do you mean, some 1k, 1 over k doesn't converge? Oh, yeah, right. Yeah, the harmonic series. Yeah, I remember that. Yeah, they just fly. They just fly. And my math professor, she really loved math, actually. But she was, like, a teacher that basically didn't held back on the technicals. And I loved math too, and I basically would go up to her after class and show her the math books I was buying. And like, I guess she was just kind of like, I guess she knew that I was actually taking the class seriously. But, yeah, so like, that was practically like an interesting experience. Isn't it minus a 12? Like, actually, like, what are your guys' opinion of that? Like, 1 plus 2 plus 3 plus 4 plus 5 equals minus a 12. I watched that number file, like, that's one of my favorite number file videos, but I know there's also another video by, what's the YouTube channel's name? I forgot. I actually gotta look at, I actually have a private library of, like, YouTube videos from, like, what is it? Like math YouTube channels. Oh, whoops. Oh, I already had it open. What was the channel's name? Because I think I downloaded the video that talks about how they're wrong about it. I think the YouTube video is called like Math the Truth, I think. I don't remember. Like when I actually like watched that number file video about minus a 12, I was like, wow, that's pretty interesting. Actually, like the reason why I want to learn the math for like physics is mainly because I was actually one of those people that got the string theory bug. But of course, if string theory is not proven to be like the theory of physics that they assume it's gonna be, I would still enjoy it like in a mathematical exercise. Because, like, you know, if string theory has gotten this much clout, like, I would be like, yo, there must be, like, a lot of mathematical beauty within the theory. But then again, if you guys have experience, like, actually seeing the stuff that's in string theory or whatever, and, like, you say it doesn't make sense, then I'll take your word for it. It's like, yeah, it's like, the math in there doesn't make no sense. Which is fair. Because I know string theory is overhyped, and I know a lot of people are getting very dissatisfied with it, especially 40 years of no results from it. Like, I don't blame them for basically saying it's a failure. That's why I think math is a little bit better, because it's like, I can look at physical theories and basically like, oh, that's really cool. Let me just turn off the study timer there, because it's going to reset. What do we got? Zeta negative 1 factorial. Oh yeah, the Riemann zeta function. I think that's what you mean. The sums. Right. I mean, I think like the Riemann zeta function is like pretty cool. Like I mean, I learned about it after I learned about like, you know, minus a 12. Okay. Before we start the next study session, I will be right back, guys. Just give me 1 second, and then we will probably go over the answers to the proofs that we weren't successful in doing. Okay, guys, we're back. Sorry about that. Alright, so not me stalling. Let's actually just go over the solutions. So, basically, since it is from Udemy, I have muted my browser so you guys won't hear it. But there will be still music in the background. I will just be taking notes, basically on the solutions. And then I will probably, like, once the solutions are discussed in those videos about the problems, I will probably just like re-review the solutions to myself, and you guys can probably tell me where I mess up on like explaining it to myself in my head. So okay, let me just turn the study timer back on so we can be in focus mode. And if anyone has any projects they're doing, or you know, just working on stuff, now is your time to basically focus on the things you need to get done and just be awesome doing what you guys are doing. A lively math stream. Is this 2021? All we need is a chemist being annoyed by a certain someone. I don't know what that means, but hopefully this hopefully my math/physics math stream is like lively enough for you guys. Because, like, I don't want it to be, like, you know, me just being an instructor and just basically just telling you guys what I know. I just want it to be, like, a good, like, environment where we just can sit and, like, just do whatever we need to do just to be awesome in our lives. And, you know, math and physics has been a love of mine for, like, over, like, I think, let's see, I graduated from, like, 2014, right? So then, yeah, it's been like, it feels like almost like a couple years since like math and physics has become my new hobby. Let's see. Take the reciprocal. The reciprocal? Wait a minute. Just give me a second. So let's see. So the absolute value of C, the absolute value of the absolute value of C minus the absolute value of D is less than or equal to, okay. Take the reciprocal. Like, I know what the reciprocal is, it's just that I'm trying to envision it in my head right now. Do you mean, like, because when I think of the reciprocal, I think flip it. Like, basically flip, like, you know, the absolute value of A plus B over the absolute value of C plus D. Like, I'm thinking, like, flip that around. So it's... cook on it. I think it will be helpful for you to see this. And also the thing of it is that I urge you guys to be patient with me, because like sometimes when I hear instructions and I know it's brilliant in your head, but at the same time, like when I try to see it, I don't do it correctly. So just be patient with me. Like I feel like Penn is like on a roll and he's trying to help me get on the same roll. So I feel like, oh my god, you're exciting me right now. So A plus. So you say take the reciprocal, so is this what you mean? We can erase this part, actually. We don't need this. Is that what you meant? Yep, we want to flip both sides. I want to do 1 over and 1 over. Oh, okay. Wait. So don't even start there. Don't even start there. Start here. Literally write down the reverse of the triangle inequality. Huh. Okay, I guess study time is now. Okay. All right. Because I feel like Penn is like, it's like that scene from Zorro, like when the real Zorro shows up, is like, when the student is ready, the master will appear. I mean, like when I started math streaming, like I feel like all you guys are just practically masters. At least masters of what I want to get good at. Okay. So you said start off with, okay. Let me just clear my head and like just basically just start off with what we know. Okay, so, oh, whoops. Because I'm trying to remember what you typed first. Okay, don't even start there. Start here. Okay, start here. So you wrote down C minus D and less than or equal to C plus D. Okay. Literally write down the reverse of the triangle inequality. Okay. This really isn't. This is really important idea I had to use so many times in complex analysis. So I think it's important to you to see it. Yeah, especially for me to actually like get into physics. Okay, this is what you meant, right? Just basically just focus on like the C minus the. Okay. And I think I wrote it correctly because that's the way you layered it. Okay. Now try to take the reciprocal of both sides. Okay. So we have to flip it. So basically it's like doom. So if we take the reciprocal, does that mean that the sign flips? No, I don't think so. Because this is supposed to be less than or equal to that. Okay. Alright. So we take the reciprocal of both sides. And then we have to incorporate a plus b. The absolute value of a plus b. And then turn that result. Wait a minute. Consider a half. Consider a half is less than 1. If you take the reciprocal, what do you end up with? If you take the reciprocal of that, then you would end up with 2. Oh, then it flips over. Yeah, it does. It does flip it. Okay, thank you. Okay, so yeah, because that's what we wanted to do, because this is, in the problem, it basically says the absolute value of that mess is less than or equal to what we need. So, okay. So, yeah, so this is the correct way it's supposed to face. Okay. Okay. Now I'm seeing it. I'm seeing it right now. Okay, you're cooking now. Can you try to get in there now? Okay, Alright. Well, then again, you did explain it before, so... The thing is that... No, because I don't want to multiply by 1. That's the one thing I don't want to do. But then again, like, if we just multiply, like, the absolute value of A plus B in there... It feels like we just pulled that out of thin air, though. Well, I feel like I'm not cooking. I feel like you just basically just, like, kind of like, what is it? What's the term? You're kind of like, I don't want to say spoon feeding, because that feels kind of like, it kind of feels like demeaning. I think you're kind of like training me to get there. You're training me to get there. So, yeah, but I really appreciate the hints. That's actually like allowing me to see stuff right now. But let's see. Yes, multiply. Oh, okay. Because I feel like that's kind of pulling it out of thin air. That's the reason why I felt like I didn't want to do it to begin with. But then again, it's math, so sometimes you just have to be clever, I guess. Okay, I think we gotta move this down. Move it to the side that way, so hopefully you guys can see that. Alright. So then up, and then we can just rewrite this as oops. So we can rewrite this as A plus absolute value of B because of the sign. Right? Because I think you showed that to me before, the triangle inequality. So, and there we have it. Okay, sweet. One more step, and you have the proof. Nicely, well done. Well, there's still one more step we have to do. How should we phrase the last sentence for this? Because I know there's got to be at least one sentence to explain everything. So I want to actually before I write that, I gotta actually review what I did. So okay, so we took the bottom and we basically so this is the reverse triangle inequality, correct? Like the one with C and D, right? Let me double check here. Yeah, so yeah, that's it. Okay, so I think what was screwing me up was like the sign changes, because I was like, I think maybe the signs were like, I was expecting it to be a certain way, and then I didn't realize that the relevance of how the signs are positioned, I guess that's what kind of made me not see it, I think. Okay, that makes sense. Okay, so that's a good thing to keep in mind, is that whenever the inequality signs are positioned, that's where it's supposed to dictate what the value is or something like that, if that makes any sense. I'm just basically trying to solidify it in my head. Okay, so how could I sum up this proof so it just seems nice? I guess thus A plus B. Well, actually, I should write in the reverse way, because that's how it was in the proof question. Thus, oops. is, yeah, it's like this. Plus right, okay. Is true. Okay. I mean, there we go. Actually, did we need all this? I don't think we needed all that. We actually didn't need this. Sometimes I put too much stuff in details because I'm like, oh, I have to be like clever. I have to see the trick or something. But sometimes I put too much. I don't really go by Occam's razor too much, and that's probably my downfall as like someone who tries to solve problems. Because I always think it's got to be something clever or brilliant, but then I just don't go with the simple approach. Yeah, totally. Taking reciprocal can help you position the signs in a way that you want. Oh, okay, that's good to know. That's good to know. Oops. Well, actually, like, Pen, I appreciate all the hints you gave me because I felt like I didn't really solve the proof on my own brain power, but you gave me, like, good lead outs to that. I mean, like, I don't know as, like, a teacher that's that's me actually getting the proof, or, like, I don't know. Because I felt like you were mostly helping me the whole way. I mean, I really appreciate it, though. Don't get me wrong. I really appreciate you giving me this awesome lesson. But at the same time, I'm like, did I really solve this proof on my own? That's the thing. That's the thing. Sometimes going on unrelated tangents happens to everybody. It's usually not seen when reading books because those proofs are optimized to be more readable. Oh, okay. The proofs you read are nowhere near the original proofs. Oh, okay. Yeah, I mean, I think, like, that's what the Math Sorcerer said whenever I watch these videos. It's like, the best proofs are the ones that you create on your own. And, like, you know, I don't deny that. I don't deny that at all. Okay, so I guess we'll just circle this because, we solved it. We solved this. We solved this. Not I solved it, we solved it. This was a team effort. Because all you guys were just straight up awesome in helping me. Especially Penn Center. Second. Right? Okay. Now this other proof. This proof was actually kind of like interesting because I was like, how do I start this? So, like, for all those that basically didn't see my last stream, I was taking notes, and like basically according to the Math Sorcerer's course, the things that we need are the triangle inequality, the reverse triangle inequality, and the Bernoulli's inequality proof. So I feel like this one might be a Bernoulli inequality proof, I think. So I'll just read it again for you guys. So let A be a positive number. Prove that if X is a real number such that the absolute value of X minus A is less than A over 2, then A is greater than A over 2, which is pretty much a given, I think. Let's erase this bottom part. I think that will distract us a bit. Okay. Alright, so let's see. Suppose that A is a real number, a real positive number. That's my assumption because it's supposed to be bigger, supposed to be less than A and a half. That's my assumption, but I don't know if that's the right approach because before I thought it was supposed to be like, let A be an integer of the positive number, like a positive integer. But since this is real analysis, I immediately changed my thought on that, and I thought it had to be a positive real number. So, I mean, like, for anyone who has experience in proofs, like, is that the right way to approach it, or should I have just gone with like it's a positive integer? Because I thought making an integer would make it easier, but I don't know if that's gonna mean anything. If A is not positive, then the set you need to prove something for is empty, so you don't need to prove anything. Okay. What exactly does that mean? Does that mean like proof is in the pudding? Hello, cellophane 11578. I'll probably if you like, hopefully I pronounced the name right. Is it okay if I call you Cello? And what's the best part of your day so far, if you don't mind me asking, since you just popped in? Okay, so now prove if x is a real number such that the absolute value of x minus a is less than a over 2, then a is greater than a over 2. Okay. So we have to prove that there is a real number x so that it has this property, and that a is still greater than a over 2. The math doesn't add up. Like what do you mean? What do you mean, Cello? Okay. Let's see. What does the Bernoulli inequality say? Prove that 1 plus a to the nth power is greater than or equal to a plus n a, for all a is less than or equal to -1, and for all n is an element of the positive integers. Wait, what? Oh, I already had the proof down here. It's like going backwards towards string theory. What? I was just talking about string theory a while ago. I'm talking like pure math. Oh, okay. I mean, like, string theory has been like helpful in like mathematical proofs, like, I think over the years. So it's kind of funny that like a theory of physics is supposed to be like mainly towards like just the physical idea of the universe, but then it's just going to pure maths and it's helping pure maths find answers to things. Which is probably why I want to actually learn the math to understand it, like not theory and stuff. Okay, so how do we... I guess this is the typical like student's way of basically saying, I see the question, but I can't think of step 1 to actually figure out how to solve it. Okay. So we have a... Yeah, so a, I think, is supposed to be a real number here. X is an element of the real number such that where you have the condition there, so then a is supposed to be less than, it's supposed to be greater than a over 2. Okay. So the question is, prove that if x is a real number such that... Huh. How did they do the Bernoulli inequality? Maybe that might help me. Oh, did they do it through induction? Yeah, they do it through induction. So the base case... So if we do it by induction, then we have to do it by 1. So by by the principle of induction. We'll start off the proof that way. By the principle of induction, so we have to prove that there's an x, so -1 is less than or equal to, which makes, right, that is correct. So this passes. We'll do it up to 2, see how it goes, and then let's see, 2 and 2, right, and then it'll be 2 over 2. That will be 1. So this passes. Okay. Now for the hard part, because we have to prove the base case, which is this, and then a. Okay, so now we actually have to do 1 plus a. So, no, I didn't have my pen active. Okay, here we go. So I think we write suppose a is equal to, well actually, I think we have to change the a to k. Make it, I think it's because I'm so used with induction with k a lot. So we'll suppose a is equal to k plus 1. Okay, so k plus 1, the absolute value is k plus 1 over 2. Meaning that k plus 1 and if you do the arithmetic here, it will be k minus 1 minus 1. Let me just drag this down here. Can that be k plus a half? Although I don't know why I did that, but at the same time, I just wanted to see if it makes it easier for me to see something. Well, you're not talking pure English. Are you saying that to me, Sensation, or are you saying it to someone else? I'm thinking you're saying it to me. Because I do speak gibberish sometimes. I don't doubt that I speak gibberish. I feel like this is the right approach, but at the same time, I'm like, okay, because we have to prove. I'm not referencing different dialects, if that's what you mean. Oh no, like sometimes I like mumble stuff and I just basically say like stuff. I just basically say whatever comes to my head. I'm not talking about dialects or anything. I just thought that maybe I'm saying stuff that like doesn't sound comprehensible. That's what I thought you meant. When you said, like, I'm not talking pure English. Actually, yesterday I didn't have a blank idea, like, actually how to, like, approach this problem, actually. Because then K, suppose K is so. So we have to actually show that this is true. This part is true. I mean, that's for induction to work for the base case. Well, come to think of it, let's see. This plus a half. And plus this. Well, technically, yeah, this would be true. Thinking about it, actually. But the thing of it is that have I proven that, though? I'm not oh, I already read that. Sorry about that, guys. I thought there was an update in chat. So, actually, this is becoming a lot more productive than I thought. Can I show you some trig formula in Desmos? I feel like you might like it. Sure. You can give it a try. I don't know if I did allow links to work, but you can probably try. Because this is a new channel I made. So I don't know if, like, I did all the kinks. Alright, let me take a look at what you got here. Oh, that's pretty. If anyone's curious. That's actually very pretty. I haven't actually worked with Desmos, actually. I mostly like writing things. I don't really like graphing that much. But then I probably should get into graphing. G and H. G and H are sign. Oh, here we go. I see G and H. Fascinating. That's pretty cool, actually. That's the thing about math sometimes. It sometimes creates some awesome beauties. I found my students make heavy use of Desmos both as a graphing utility, but also as a direct calculator for some reason. Oh, I see. I still have my good old, what is it? TI-84. I'm pretty sure it's really old now, but it still works charms. I really love my TI-84. Desmos is beautiful as a grapher. I probably will have to learn Desmos from you guys, so I can actually like learn how to create awesome stuff like what Cello presented. Thank you, Cello, for presenting that. That actually looked very beautiful, actually. Closed form trig formula. Yeah, actually, like, you know, being able to see trig identities through like actual graphs, it does look pretty. I rely heavily on TI-84 too. Yeah, nice. TI-84s. I mean, I know the other ones, they can do like almost every type of math operation, but at the same time, like I can't get away from like the classic TI-84. Okay, back to what we were doing. So we proved that this works for like the first two cases, like from 1 to 2. That's good to know. I probably should have done it for 0. I probably should have tried it for 0. But then again, 0 wouldn't work though, because 0 would be less than itself, which doesn't make sense. So it's a good thing we didn't do 0. It's a good thing we didn't do 0. So the base case, I mean, the way it looks like it's reasonable. The thing is, wait, hold on. So x is a real number where like the absolute value of x minus the minus what we got. Nearing Monday, nearing midnight on the countdown starts, the ball drops. Calculations run on. I was like, it's not New Year's, and I'm like, oh, I was like, that's you were just like making up a scenario. Non-dairy neutrino. That's funny. That's funny. Yeah, actually, non-dairy neutrino, like I did take an online course on physics, but it's been a long time since I've done like actual physics problems, like on the I guess university physics level, quote unquote. But at the same time, it's like a part of me does want to read a little bit into classic mechanics, but at the same time, I don't know partial differential equations or the calculus of variations. So I feel like I answered my own question at that point. Because I just remembered that classic mechanics does use the calculus of variations, and I don't know how to do that yet. I don't even know how to do partial differential equations yet. I mean, I know what a partial derivative is. I just haven't done like partial differential equations, which is probably much tougher than differential equations. And actually, like, a big question for you guys, right? Do you guys like it when I mix up the math, or do you guys just want me to do like a standard linear path where it's like, oh, I'm doing real analysis, so I'll stick to real analysis until I totally finish the whole real analysis like requirements and stuff? Because I want to be able to improve like the content on this channel. I was just watching a video on calculus of variations earlier. Oh, nice. Was it really tough for you, or was it like, oh no, this is easy? Like it was just a snap of the fingers easy. Do whatever you like? Okay. Yeah, because I also have a YouTube channel as well. So I'll be uploading each VOD to like YouTube. Because like, I kind of consider my YouTube channel sort of like personal notes. Because I'll probably will forget. Do Archimedes cosplay? What? That's random. I was making sense. It was making sense because I've seen some of it before, although I don't know it well. Oh, I see. I see. A lecture by Leonard Susskind. Oh yeah, I wouldn't be able to learn enough math and physics so I can actually watch lectures by Leonard Susskind. So let's see here. So x minus k minus 1. So, I mean, if x is supposed to be a number where it's less than, because it's taking away from k and it's also taking away from 1. So technically that could be true, because like it's taking away from k and 1, so I'm guessing because of that, if x is a real number to the point where it actually takes away from k, because k, like if k and a half is supposed to be less than that, it's got to be to the point where it actually takes away from more than half of k and 1. mean, I feel like it's true, but I don't know if this is the right way to write the proof that it's true. That's the one thing I don't know. Because I feel like proof by induction is actually helping us at this point, but at the same time, it's like, am I doing the proof right? That's the real question. The best place to start for mechanics is getting familiar and developing the intuition with actual physics by working with problems on vectors, displacement versus distance, velocity, acceleration, force, static equilibrium, dynamics, work, kinetic energy, potential energy, momentum, conservation laws. I use Knight 5th edition with my students. What's the statement? The theorem. So the proof we have to prove is this. So let A be a positive number. Prove that if X is a real number such that the absolute value of X minus A is less than A over 2. Then A is greater than A over 2. So far, I've done proof. I'm trying to do proof by induction to see if this works, because it seems like it could be a method that can work. The one thing is that why I'm stuck is that I don't know if I've formally proven that that is particularly true in this case. Wait, what? Isn't A greater than A and a half always? Yeah, that's what I thought. I guess, like, the thing of it is that in the question, that's what it says. So let's take a look. Oh no, that's not what I wanted to do. Inequalities. Let me see if I wrote the question right. Yep, that's what it says. The question is that let A be a positive number. Prove that if X is a real number such that the absolute value of X minus A is less than A and a half, then oh, oops. I actually wrote something wrong here. Thank you for actually asking that, Penn Center. Actually, it's supposed to be X is supposed to be less than that. Okay. Now I see the flaw in my logic. I wrote the question wrong. Oops. So we have to erase all this. Thank you, Penn Center. If you didn't ask that question, I would have actually just gotten, like, really lost. So it's supposed to be X. That's less than. Okay. So then we have to replace everything then. We're gonna have to do proof by induction all over again. Okay, so that's one part why I got lost. That makes more sense. Right. Thank you for pointing that out. I wonder if it should be X. Yeah, you were right. It should be X. Okay, so basically we'll do it by 1. So minus X. And then 1 is greater than, oops, no. Greater than A and a half. Then if it's 2, then, see. The thing is that I don't think A is supposed to be defined. So the base case is basically, we'll just put K minus A less than, so that X is, well, it's K. K is supposed to be equal to X. So, okay. So, if it's K plus 1 minus A, k plus 1 is... So... Wait, hold on. I think I see something I can do. I could be wrong. I could be wrong in doing this, but... Let's suppose we do... this. Okay. I don't know if this is the right approach. I'm just basically just doing what I feel might be, like, interesting to do. I guess as math, like with math, we have to learn to play with it. X is a real number, so you won't be able to use induction here. Oh, okay. So my approach has been entirely wrong then. So when do you use induction? Is it only for like integers and like whole numbers? And pardon me guys, if it sounds like I'm chewing it, I'm just basically taking a cough drop. I'm not sick or anything, it's just that whenever I do streams and I talk, like, I just put a cough drop in so I can just, like, make my throat feel less, I guess, like, less sore. Oops, we're really zoomed out. Might as well just zoom in here. Oh, I accidentally erased my supposed section, so... Suppose A is, I'm just thinking a real positive number. Actually, Pen, I have to ask you something. When they say like let A be a positive number, do they mean like a positive integer or a positive real number? Such that usually a real number. Okay, I wasn't wrong on that. Okay, thank you for clarifying that for me. It will work only when X is a whole number. Okay. Okay, so I'm thinking that maybe induction really helps with like number theory, maybe. I don't know. Like, I'm just spitballing here because I know number theory. Well, I shouldn't say I know. I've heard that number theory is more targeted towards like the basic operations like arithmetic and like, you know, the operations within integers and whole numbers. That's what I heard. I don't know if it's typically true. Like you theoretically should be able to prove this, but it won't prove the original theorem. Since you will prove it for whole number X, not real number X. Oh, okay. Usually real numbers. Okay. Could you use induction on rationals, cause they're countable? Or is there a more fundamental placency on something like the notion of a successor? Yeah, you should theoretically be able to make it work as long as you find the bijection. Oh, okay. Interesting. Well, I'm glad you guys are exchanging brilliant ideas with each other. See, this is what I like. It's like basically just create an atmosphere where like, I'm not going to say scientists, but more like intellectuals just exchanging different ideas and seeing what works and what doesn't. Like, it's not like we're in a library, but it's more like we're like in a chill, like, break room. but at the same time we're all doing our own thing and just basically just bouncing off ideas with each other. And it's like, hey, can you help me with this one problem? It's like, sure, I'll help you with this problem. And it's like, yeah, do you know the solution to this problem? And you guys like are just helping out each other and that stuff, and also helping me. More likely helping me because I am the streamer. But then again, like, I'm not entitled to, like, you know, your guys' helpful advice. Because you guys are also trying to make me a better person by being a better mathematician. Well, not better mathematician. Like, I should say math-magician, in a way. Because, like, I don't think I would be able to get a PhD to, like, do, like, mathematics as, like, a full-time career. I would probably prefer to be, like, you know, the typical route where, like, people are like, I want to be a professor and teach people. But, you know, there's a lot more to a PhD than just teaching people in a university setting. I wish I has a brilliant idea, but I usually just have ideas. That's fine. Ideas can, like, help you go through, like, different stages. Well, we have like 29 seconds. I'm just trying to see what I need to do for this proof then. Because the only thing left are... Unless it requires like something else I have to do. Because we only have the Bernoulli identity, the Bernoulli inequality, we have the reverse triangle inequality, and we have the triangle inequality. Oh, I guess it's break time. Well, at least with this stream we managed to do, well, I mean with your guys' help, like massive help. I will say massive help. You guys helped me solve the one that I was struggling with yesterday. So, you know, that's an achievement, right? We solved it together. This is our proof, actually. I probably will try to remember this proof. I probably won't forget it. It's like, this is the proof that we as a community solved together. But this one is probably gonna be, this one is probably gonna, like, eat at me for a while. But like, how are you guys doing with your ventures? Let's see. Yesterday I told an ex-NASA employee he doesn't understand particle physics. Actually, Cello, do you mind if I ask, like, what is it? Are you a student, or are you like currently working? Like, what is it that you do, if you don't mind me asking? I'm pretty sure you're like doing something like something productive, something like very interesting. Because actually, like for everyone in the chat, like, I want to ask you guys something. Like, what was it that made you guys, like, go into math, actually? Like, what is it that, like, got you interested in math to begin with, actually? Mine was physics. I really liked how math interlocks with physics. And that's when I decided to, like, get into math, because I like the equations in physics. And I love the idea of just basically having equations and just messing around with the parameters to see what happens. You know, I think that's a really interesting idea, because it's like, oh, I can use math to, like, tell me how the universe will behave. Of course, like, I'll actually, like, non-dairy neutrino, like, I have to ask you something. Like, for, I guess, like, for physics in general, right? Like, when does proof, does, like, mathematical proof techniques come in handy for you? Like, when you're doing, like, physics problems? Or do you feel like, nah, it's just something that only math majors do? Because the reason why I'm doing proofs is because I feel like it's necessary for, like, understanding, I guess, like, theoretical physics a little bit. Or at least the techniques that theoretical physicists use to solve, like, complex physics problems. Let's see. I live as a programmer, but Currently thinking about hacking physics. Hacking physics in what way? That's the real question. I've always enjoyed math. I think what got me hooked on it was recreational math, like math puzzles. Oh, okay. That's fair. Because, like, actually math, like, its problems are like puzzles, yeah. I always find it interesting that math questions turn out to be very, very intriguing, but at the same time, you might think that, what's the use of asking that question? And then we find an application that somehow revolves around that type of scenario, and then suddenly it just works, and then suddenly we just like, oh, so that's how it's supposed to behave. Well, I come to believe that my school's supercomputer is just too old to do what I want to do, unless I want to write actual CUDA? What is CUDA? Is that like another language? Is that like another computer language, or is that like something else? Yeah, like, I mean, like, being able to, like, stream for you guys and actually being able to provide, like, content for you guys, even though, like, for me, it's just basically me just being a student and just, like, kind of just doing math, like, off the cuff, even though I'm not very, very good at it, I feel as if, like, with the goals that I've kind of set for, I guess, this channel in general, or just for myself to get to certain educational or intellectual goals, I really don't like the word goals sometimes, because I'm a very intentional person. Like, I learn math because I intend to get better at it, and I intend to understand the universe. Or I intend to actually understand the universe better, if I can phrase it that way. Because, like, I don't exercise to basically say, oh, I'm gonna lose 10 pounds by the next month. I basically exercise because I intend to be healthy. But then again, like, you have to be both goal-orientated as well as intentional in life. You can't be, like, one or the other. At least as far as I'm concerned. Because I feel like, for me, I've been more intentional with the things I've done in life. And I feel like that's gotten me to a place where I feel at peace. Usually when I set goals, it feels as if I have to, like, set something up for something else. Or someone else. Not for myself. If that makes any sense. I mean, like, I'm, like, kind of, like, happy that we managed to, like, get up to this point. You know, like, and for you guys to actually make chat, like, very, very, like, very preppy with, like all your chatter and stuff. Because, like, it really brings a smile to my face. Really, it does. Because, like, when I see chat active, I'm like, wow, that's, like, really makes me feel like, wow, I'm actually part of, like, a community, you know? So you guys make me super happy. And wherever you guys are, like, whether you're students or whether you guys are working in the field doing, like, awesome stuff or just doing things, I hope you guys know that you're just, like, supported all the way. Hey, Cube, how's it going? Hope you're doing well. Yeah, we're doing all right. Basically, we're just, like, during our break time, and I think it'll be the last break we have because we managed to solve, like, well, like, thanks to chat, I'm, especially our friend Penn Center, we managed to solve a proof that I didn't figure out yesterday. Yesterday I did this proof, and, you know, well, like, a lot of chat helped me with that one too. But, like, you know, like, I'm kind of happy that we managed to get this proof. And I learned some new things. So, like, you know, like, I try to learn as much as I can from you guys. Everyone has, like, a thing to, like, offer. Because actually, like, I remember watching, like, videos on YouTube where they were talking about, that there's no such thing as, where is it, meritocracy? Where it's like, if you work hard enough, you can get to success. And I think, like, it's basically one of those partial truths that we as humans have come to acknowledge, because obviously, like, you know, like, if hard work doesn't get you anywhere, then how do you explain the people that start from nothing and they got to somewhere? Like, you know, whether it be rich or whether it be just, like, their own, like, home. Like, their own house and home and family and stuff. Like, I feel like there are exceptions. Like, there are, like, people that will be the anomalies and they build something out of nothing and then they manage to make it work. But then again, like there's like a majority of people where like, like say if a person becomes an actor and a whole bunch of people in their family become actors because of like the connections that the person that became an actor like had in the industry. So it's like sort of like a continual thing. So the thing of it is that, yeah, like, we do have to work hard for what is it that we want. But at the same time, like, I think it's like we have to question exactly why are we working hard for. I think that's the one thing. And also we have to know that every job is important, like whether it be a janitor or whether it be a garbage man or whether it be like an executive. An executive is just as important as a garbage man. Or a scientist is just as important as, say, a nurse that's working in the hospital. Like every job is just equally important. But I think a lot of people, like when it comes to like the stress of a job or something like that, whether it be in like the medical industry or whether it be in business or whether it be in like government or anything like that, they always feel like that there's some sort of gauge, and usually that gauge is money. So like I feel like we have to like look at like when someone succeeds, we all succeed. And that's the mindset I've kind of gotten into lately. Because I mean, all you guys are here and I hope you succeed, because that means that you're succeeding for everybody, and that's really good. And that's awesome of all of you guys. Even though if you guys are struggling or going through some stuff like within your own lives, just know that you're supported. And just know that you're just straight up awesome, like, and brave to go through like the ordeals that you're going through. But yeah, like, personally, I just want to personally thank you guys for that showed up in the chat, and I really appreciate that all of you guys are here. Because, like, I'm just glad that I'm able to meet people that are just so knowledgeable about the stuff that I am passionate about, especially math and physics, actually. Because, like, I want to be able to learn as much as I can from you. And hopefully you get something out of my streams as well, because the thing is that, like, I feel like I am not very, like, entertaining. I always feel like I'm a very boring person. So I just do this because I feel as if it's to increase my skills as well as like put myself out there in content creation. So, like I always put on, like, whenever I apply like through like to like other jobs like on Indeed, I would always put content creator and self-employed. I mean, I do have my resume up there, but at the same time, I don't have any like big on paper experience. So for me, I just feel like the experiences that I will make in my, I guess, a quote unquote career, even though I don't like using that word, is more towards just content I create for you guys. And I feel like that's like good enough. When it comes to mathematical physics, you're doing proofs and behaving like a mathematician. Otherwise, not really. At least in the sense that a mathematical proof has a distinct structure, flow, and goal. That's not usually what a lot of other physicists care about. For example, the mathematical physicist will write up a proof that some integral has 2 as a lower bound, while other physicists will numerically integrate the linearized integrand to get like 2.00000001. I probably didn't read the amount of zeros, but thank you for explaining that, non-dairy neutrino. I feel like I'm going to learn a lot of physics from you, especially like how active you are and how honest and generous you are with the info that you have been providing for me. Because I feel like I want to be like a generalist when it comes to like physics and mathematics. Because like, like obviously I don't think I will be like a physics researcher or a mathematician, but I feel like I want to be able to be that person that basically, like, if people want to get into that type of field, I would like to basically talk to them and like basically say, oh, in order to like get a career in like the sciences, you have to talk to your professors, you have to actually like make connections with like the people in the department, that sort of thing, or be curious about the research that they're doing, because like in college, like people don't realize that sometimes they don't realize that they can talk to the professors and the professors can help them get to a position where they need to be if they want to be like a scientist or someone related, like in a technological field. It doesn't even have to be in academia. It could be like something like in another company or something, you know? But yeah, it's like I hope my streams have been like at least this stream. I hope that for the people that came in, I hope you guys are like liking what I'm doing here, because like I just want to be able to learn from you guys as well as learn on my own as well. But big special, like I know I've said this many times, but big special thanks to Penn Center for like helping me with all this. Not with like basically with the problem, because like those hints really helped, and it allowed me to actually get a bigger picture of what I needed to see. Yeah, I like the content. It's refreshing from what I normally see on Twitch. I hope so. I hope so. Thank you, Cube. I always love the reassurance that you always give. Actually, guys, if you're into games and horror games and stuff, I'll give you a shout out, Cube, since you're an old friend of mine. Cube follows me on my my original channel, so he's just straight up an awesome person. So if you guys want to like chill and have someone give awesome vibes, you can check out Cube Games channel. He not only plays horror games, but he also does karaoke nights as well. I sometimes pop in once in a while on his karaoke streams. So if you guys want to sing your hearts out, you can do that. Okay, guys, I hope you guys didn't mind me rambling for the last couple 15 minutes, because I just want to be able to interact with you in the best way that I could. Anyway, guys, thank you for joining me on today's stream. I will upload this on YouTube, so if you missed it today, you'll be able to catch it back on YouTube. Just in case if there was any knowledge that you felt like that I did in the stream and you just didn't catch it because I went too fast, you can go on YouTube, so you can have access to my Math Spellbooks YouTube channel. And if you guys also want to check out my original Twitch channel, which is Uncle Talks, I play video games there as well as chat with you guys on there as well. I play like a lot of gacha games and stuff, so if you're into like Honkai Star Rail, Genshin, Zenless Zone, Wuwa, you know, like give my other channel a follow if you would like to keep up with that content, because I'm actually planning to play more of the story within Zenless Zone, Honkai Star Rail, and Withering Waves, because I really have to catch up on the stories of those games. So if you want to see my reactions reacting to those games, please be sure to do so. Okay, guys, I think I've said everything I need to say to you guys. I hope you guys have an awesome day. And always remember, guys, as I always tell you guys on both channels, always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in tomorrow on the next stream. So take care, guys. Bye-bye.